The Fenwei Graben is a graben that occurred in the center of the North China Craton, and it is one of the most important major tectonic movements. It controlled the distribution of coal types in the entire North China region and the patterns of coal quality changes. For the North China region today, it plays a crucial role in the deposit, development, and application of coal. I first realized the significance of the Fenwei Graben in 1982. At that time, I was at the Provincial Coal Industry Department and was sent to the provincial government to participate in the feasibility study and planning for the construction of Shaanxi's heavy energy and chemical industry base. During this process, I first discovered that the advantages of regional economic development are highly correlated with regional tectonics. Later, when I was developing the international market for coking coal for a state-owned enterprise, I found that when developed countries came to purchase Chinese coking coal, all the high-priced coal, after much searching, eventually traced back to the structural system of the Fenwei Graben. Therefore, I started registering the Fenwei trademark 25 years ago and registered my newly established company as Fenwei Energy Consulting Company Limited. The Fenwei Graben occurred in the central part of the ancient North China Craton. The North China Craton, its area is approximately south to the Qingling Mountains, north to north of Inner Mongolia, and west close to the boundary of the Qinghai-Tibet Plateau. This block was a very rigid and stable tectonic block during the coal formation of the Carboniferous and the Permian periods. It only experienced overall uplift or overall subsidence. When the sea level rose, it was submerged. When the sea level dropped, it was above ground. This is how a large number of stable coal seams were formed during this process. It wasn't until the end of the Triassic period that the Yanshanian orogeny occurred. The central part of the North China Craton's base fractured, and magma began to rise, driving the regional strata to uplift continuously. During the uplift, the highest part of the uplift created tension on the Earth's crust. This tension created faulting, which formed a series of faulted basins along the Fenwei River and a series of faulted basins along the Weihe River, which is the preliminary formation of our current coal structure. After the Yanshanian movement, it entered a relatively stable period. This is when the Jurassic coal-forming period occurred on the basis of the Yanshanian structures. Around the Fenwei Graben, the Jurassic coalfields were formed again. After less than another 100 million years, the Fenwei Graben entered another unstable period, which we call the Himalayan orogeny. The outcome of the Himalayan orogeny formed the ecological environment and geographical landscape of our present-day Fenwei Plain. The Fenwei Graben was thus completed. Due to the Yanshanian movement, coal buried several kilometers underground was uplifted to its current position. At the same time, because the temperature in the center of the Fenwei Graben is higher than in the surrounding areas, it had a significant impact on the coking coal structure of the Fenwei Graben. First, large-scale anthracite, meager coal, and lean coal are mostly found in the most tectonically active areas of the Fenwei Graben, where the temperature is highest. Yangquan's 38-degree belt is one landmark, and Jingcheng is another. These are the two core areas of the Fenwei Graben. Second, a coal seam from the same era in the middle of the graben will show a gradual decrease in metamorphic degree as it extends outwards. For example, taking the Xishan coalfield as an example, in the Xishan area, the coal is primary coking coal and fat coal. But when you get to the Hekbaud area, the same coal seam becomes gas coal. For example, in the Lingfen area, it's permo-carboniferous fat coal. When you move further away from the basin, becomes gas coal in the Shandong region. For example, for Jurassic coal, in the Ordos region, it is weakly caking coal, but when it goes south and gets closer to the Weihe Basin, it becomes gas coal in the Huangling area. This is a trend of horizontal change around the Fenwei Plain Basin. Third, due to the intense magma activity and elevated geothermal heat in the Fenwei Basin, the geothermal gradient from the surface downwards is significantly higher than in other regions. Therefore, when we mine and use coal, in some places far from the Fenwei Basin, for example the upper and lower coal formations, when the two seams are 30 to 50 meters apart, from a lithophase analysis, they appear to be a single type of coal. However, in areas closer to the Fenwei Basin, the upper and the lower coal formations will show a change in coal type. They are not the same kind of coal. Even for the same Permian coal or Jurassic coal, if you analyze the upper and lower parts of the same seam, they will turn out to be two different types of coal. Fourth, based on the Fenwei Graben's control over resources, we can also make a forecast for the future of resources within the Fenwei Graben's tectonic scope. We have a large amount of predicted resources within this area. We can't currently know their exact coal types, but based on the principles of tectonics, we can be sure that in the future, as mining depth increases, the coal quality in many of our regions will become more like coking coal. For example, we generally consider Datong coalfield and Ningwu coalfield to have large resources that are currently dominated by thermal coal. We can predict that if we go deeper, the current thermal coal will become coking coal, the current gas coal will become fat coal and primary coking coal. This also includes our Heidong coalfield, especially the northern part of Heidong coalfield. These large resources, when we go deeper in the future, we will find them gradually transitioning from the current large quantities of gas coal or weakly coking coal to primary coking coal or fat coal. In the future, the resources within the Fenwei Graben will increasingly tend to produce more coking coal. Within China's coking coal system, its proportion will become increasingly larger. The role of coking coal produced in the Fenwei Plain in China's steel and coking industries will increasingly grow, and it will become more and more competitive. This will have significant strategic importance for Shaanxi, North China, and even China's entire economic development.